Welcome. On this video, we're going to talk about some properties for logarithms. So let's get started. Now, the properties that we're going to be using today are properties that we will use whenever we want to manipulate algebraically logarithm functions. And there are three properties that we're going to be using throughout this chapter. And that is the product property, the quotient property, and the power property. But what are those properties? Well, let's start by discussing the product property. What the product property says that for any logarithm functions regarding the base, it doesn't really matter what the base is, notice that we have two expressions inside the parentheses, u times b. That's why it's called the product property, multiplication property. So if we have two expressions that are multiplying inside the logarithm, well, that is equivalent to just getting the first expression. So take the log of the first expression, which in this case it's a u, and then add the log of the second expression. And that's what the product property is saying. Take the log. If you have two expressions that are multiplying inside the log, well, that's equivalent to just taking the log of the first expression plus the log of the second expression. And very important, now that we're writing in multiple logs, they have the same base that they started with, which is base a. And the same can be said about the natural logarithms. So regardless if it was just a regular log or a natural logarithm, the rule still applies. So notice that in this natural logarithm, we still have u times b inside the logarithm. So that is still equivalent to ln of the first expression, which is u, plus ln of the second expression, which is b. So that takes care of the product property. Now, what's the quotient property? Well, the quotient property means division. So now, what happens if you have two expressions that are dividing inside the logarithm? Well, that is going to be equivalent to taking the log of the expression on the top, which in this case is u, and now we're going to subtract the log of the expression of the bottom, which is b. So what this is saying is that for the quotient property, inside the log, if you are dividing, well, that's equivalent of taking the log of the top minus the log of the bottom. And the same can be expressed for the natural logarithms. The only difference is that we write ln. So this is equivalent to ln of u minus ln of b. So that takes care of the quotient property. And the power property, that takes care of the exponents. Because now there might be times where perhaps inside the logarithm, we have an exponential expression. So here we have an expression, which is u to the n. Now, if you have an exponential expression inside the logarithm, what we can do is we can get the exponent of this function and then bring it to the front. And that's what the power property is saying. So this is equivalent to n times the log of u. Again, all we did, if the exponent is inside the logarithm, we can just get this exponent and just bring it to the front. Now, one thing to keep in mind, that is not true if my expression is written as this. This is on this the power property, it is only true if the exponent is inside the log. Notice that here in this case we have an exponent outside the whole logarithm, so we cannot just say, well, I'm going to get my exponent and just bring it to the front. No, this is only true if we have an exponential expression inside the logarithm, so we can just get the exponent and bring it to the front. And the same rule applies for natural logarithm. We can just get my exponent and then bring it to the front. So that would be n times ln of u. So these are three properties that we're going to be using whenever we want to manipulate logarithm functions algebraically, where the product property, it states multiplying inside the log, that's equivalent to adding each expression individually inside the log. The quotient property saying dividing inside the log, but that's equivalent to subtracting each expression individually within its own log. And the power property, it's saying any exponent can be brought to the front as long as the exponent is part of an exponential expression inside the log. So how can we use those properties now? Well, let's take a look at some examples. Because now, these properties, we can use those properties to either expand or condense logarithm functions. So what do we mean by expanding or condensing? Let's take a look at some examples now. Now, for the following three examples, we want to expand the logarithm function. In other words, we want to write this expression into multiple logs. And the way that we're going to tackle this is first identifying what's happening here. Well, here we have a logarithm whose base 4. And now inside the log, we have 5 times x to the third times y. But notice that here, inside the logarithm, we are multiplying expression. There are 3 expressions that are multiplying, 5, x to the third, and y. So notice that we can use the product property because the product property talks about multiplication inside the log. And what the product property says that if you multiply, get each of those expressions individually and add them up. So let's do that. So this is equivalent to the log of 4 of the first expression that we're multiplying, which in this case is 5, plus the log of the second expression that we're multiplying, which is x to the third, plus the log of the fourth expression that we're multiplying, which in this case is y. But before we go any further, notice that I keep in the same base that I started. I started with log of base 4, so now each of those additions will have log of base 4 as well. So once we have it in this form, this is an expansion, because notice that we have 3 logs. We started with 1 log and we expanded into 3 logs. But before we make this our final answer, notice that there is still one more thing that we can do to this expression. Because notice that we have an exponent. Notice that we have an exponent of 3. And the rule says that if we have an exponent, we can always bring it to the front. So let's just rewrite that. So now we have the log of base 4 evaluated at 5 plus 3 log of 4 to the x plus log of 4 evaluated at y. And now this is as far as we can go. This is the log. This is the expansion of the logarithm expression that we were given. And all we did, we apply first the product property and then the power property. So now let's take a look at another expression here. Now, the task, it is still the same. Let's expand the following. Well, whenever we have a square root, notice that neither one of the 3 properties talks about square roots, but we know that we can rewrite this square root as an exponent. How can we rewrite that as an exponent? Well, this is equivalent to 3x minus 5 exponent 1/2 over 7. Any square root is going to be equivalent as an exponent of 1/2. So now that we have this, let's think about this for a second. We want to expand this. Well, the first thing that I notice is what's going on inside the natural logarithm. And inside the natural logarithm are 2 things that are going on. First, we have an exponent, and second, we are dividing. So whenever we encounter those situations, first we're going to take care of the division. So we can use the quotient property. And the quotient property says that if I have 2 expressions that are dividing, I can take the log of the top and then subtract the log of the bottom. And that's exactly what we're going to be doing here. So now this is going to be equivalent to ln of the top minus ln of the bottom. So we have that. So now that we have this, we have definitely expanded. But there is one more thing that I can do to this expression, because notice that I do have an exponent here, which is 1/2. So thanks to the power property, I can just say, well, I'm going to get this exponent and just bring it to the front. Well, let's do that. Let me just get my color. So I can get this exponent and just bring it all the way to the front of ln. So now this is just going to be equivalent to 1/2 ln of 3x minus 5 minus ln of 7. And this is as far as we can go. You might be tempted to say, well, look, I am subtracting inside the natural logarithm, but there is no product that we can use, because notice that the only way to expand is if we either multiplying or dividing inside the logarithm. There is no rule that says, well, what's going to happen if we subtract inside the logarithm, which this is as far as we can go. So let's just box our final answer now. Now in the last example, notice that this is almost the same as the first example, because we still have 3 expressions that are multiplying. So let's just do this one quicker. So notice that there are 3 expressions that are multiplying. So I'm going to get the first expression, which is x, and I'm going to add the second expression, which is y, and then I'm going to add the third expression, which is z to the second. And again, notice that we do have an exponent here. So by the same reasoning, we can just get this exponent and just bring it to the front. So this is equivalent to just log of x plus log of y plus 2 log of z. So these are just 3 small examples that can just illustrate the idea of using those properties to expand logarithm expressions. So how about we do the opposite? And now let's take a look at some expressions where we want to condense, where condensing is exactly the opposite of what we were doing. We started with one logarithm expression and then we write it as multiple logs. Now what we want to do is we get multiple logs and we want to write it as one single log. Now one thing to keep in mind is that whenever we want to use condensing, or whenever we are condensing, we have to see that, well, first we are adding 2 logarithm functions. They need to have the same base. The logarithm of the first base is 10. The second base of the logarithm is the base is 10 as well. So therefore, we're going to be allowed to condense it. If we have examples, whenever we have logs and they don't share the same base, then we cannot condense it. So that's just one requirement. They need to have the same base in order for us to apply the properties that we were discussing at the beginning of this lesson. So let's just do some examples now that we got those requirements out of the way. Well, the first thing to keep in mind is that notice that we do have a coefficient in front of the log, which is exactly the opposite of what we had here. Because we said that if we have an exponent, we can bring it to the front. So we're doing the opposite. If we have that coefficient, we can bring it as an exponent. And that's the first thing that we want to do. So we're going to get our 1/2. And now we want to bring it as an exponent of the x. And we want to get this 3 and bring it as an exponent of the whole expression. And if we do that, we're going to end up with log of base 10 of x to the 1/2 plus log of base 10 of x plus 1 all to the third. And we still want to condense it, so we still want to add it. We still want to write it as a single logarithm. So what do we do now? Well, notice that we're adding 2 logarithms. So since we're doing the opposite, I know that if they're multiplying, I can add them. So if I want to do the opposite, if they're adding, I can just multiply the insides and write it as a single log. So now I'm going to take a look at the expression of the first log, which is x to the second, the expression of the second log, and now we just want to multiply them. So I'm going to open up a big parenthesis, where in the first parenthesis is going to be x to the 1/2, and now that's going to get multiplied by x plus 1 all to the third. And now notice that this expression that we have here, it's a single logarithm. There is only one logarithm in my expression, so that's okay for us to do. And that's exactly what we were looking at. We wanted to condense it, and to condense it, we want to just write it as one single logarithm. So let's take a look at example B. Let's just do one more example of this. Same idea. Notice that I have a coefficient, which is a 2. Let me just bring it as an exponent. And that's the only thing that I can do first. So now I can just rewrite this as ln of x plus 2 But now this has an exponent of 2 minus ln of x. Now notice that in this case, I am subtracting. So therefore, I want to think about the quotient rule, because the quotient rule says that I have two logs and they are subtracting. I can just divide the insides. So therefore, using that property, the quotient rule, I can just write it out as a single log. Let me just open a big parenthesis here. And now I can write down the expression on the top over the expression at the bottom. And now notice that there is just one single ln, so we have condensed the expression now. So the last example that we're going to be discussing today is example C. And there are two ways that we can tackle this problem. The first way is that I am just going to start working inside the parentheses. So I'm just going to omit the 1/3. I'm just going to assume that it's not even there and just concentrate on what's inside the parentheses. But notice that inside the parentheses, this big parenthesis or this big bracket, I have log of x plus log of x minus 4. There are two logs that are adding, so therefore I can just multiply their insides. So now this is going to become log, big parenthesis, of x times x minus 4. And now that I have this, well, perhaps this bracket is not necessary anymore. Maybe that's just extra, that we don't even need that. And now notice that we just have one coefficient here, and we have the coefficient of 1 to the third, and that is in front of the log. So therefore, I can just use the exponent, the exponential property, which we refer to it as the power property. And now we're going to say, well, that big exponent is just going to affect everything that is inside the log. So we have x times x minus 4, and this is going to have an exponent of 1/3, the whole thing. Now, the second way that we can tackle this problem is, well, let me just rewrite the problem. So we're going to have 1/3 log of 2 of x plus log of 2 of x minus 4. I can say, well, before I do anything with the logs, I can just distribute this. Oops, sorry. I can just distribute this to both of them. So now I'm going to have 1/3 log of 2 of x plus 1/3 log of 2 of x minus 4. And now I can just get it and just distribute individually. So now I'm going to have log of 2 of x to the 1/3 plus log of x minus 4 to the 1/3. So now we're adding. Notice that we're still adding that logarithm. So I can just rewrite this as just the log of 2, big parenthesis, x to the 1/3 times the log of x minus 4 to the 1/3. And since I have the same exponent, which is 1/3, and they're multiplying, I can just rewrite this as the log of 2, big parenthesis, x times x minus 4, all to the 1/3. And notice that we get the same expression that we do have here. So with this, it concludes our lesson for the properties of logarithms.